Hey there, space weather types. Welcome to the Daily Space Weather Show. And today we've got a little uptick in the solar X-ray flux, a little uptick in sunspot number, which might not have been expected. The most active region would be the eastern limb. And let's cut to some custom 24-hour videos. There is the SDO 171 angstroms wavelength in all its glory, and we're going to actually add 304 angstroms here to show some additional data, all rolled into one convenient 30 frames per second video. We do have some plasma instability, especially in that southeastern limb, and additional active regions, likely sunspots, are also rising over there. We've also got some prominences, which is simply when a plasma filament is hanging off the edge of the Earth-facing portion of the solar disk. As you can see up there, some crown prominences larger than planet Earth. Here's the equatorial view. A great view there of the closest star. Not half bad. Not half bad. And there's our southern hemisphere. Crown prominence is down there at the south polar region. And we put the Earth scale up there on the eastern limb just to show you the size of some of those prominentiary features. The most likely sunspot to produce a large flare is to the southwest of Earth. On that image there, that will be sunspot 3738. That will be down and to the right from the Earth scale image. And let's take a moment to press the like button if you haven't already done so. If you're new to the channel, press subscribe, press share, etc. Press comment. Enhance the likelihood that the video will actually be seen by your friends and foes, perhaps on your social media accounts and so forth. And I've changed colors. That's a little bit better, I guess. Not bad. Yeah, thanks for tuning into the Smash News Network, least busted name in news. We only bring you the world's most comprehensive daily space weather content and most detailed solar imagery you'll find in the known universe. Now, we've got a quote for you here in a moment. Also, you can find links below the video to our merch if you haven't ever checked that out. Go have a look. All kinds of links there. Again, press share, visit us on social media, etc. That would be in order of best selling. We won't even show you the top sellers. You'll have to go find that yourself. Today's quote is, "Every decent con man knows that the simplest truth is more powerful than even the most elaborate lie." And of course, this brings you to Occam's razor, right? I say it all the time on the channel. Never blame a conspiracy on that which is more likely attributable to basic stupidity and ignorance. And never trust a theory that requires half a dozen extremely unlikely prerequisites in order to be the case, when a simple explanation is more likely the case. I mean, Occam's razor. If it requires aliens and demonic possession and stargates and tens of thousands of people conspiring to, dupe people, is that more likely? Or is a simpler explanation more likely? Ask yourself this question, that quote from Allie Carter about con men. And hopefully you're not being conned about things like space weather, earth weather, geophysics, etc. Getting back to some space weather stats here, the 10.7 centimeter radio flux is currently at 166 solar flux units. Again, we did have an uptick in the X-ray flux as well, which we'll get to. There is the 10.7 centimeter radio flux over the past year. And you can expect to continue to see higher highs and higher lows, at least for the next few months. Moving right along to the Space Weather Enthusiast dashboard. Now, we did see a coronal mass ejection impact today. It was very minor. The magnetic fields were weak, but it showed up right when we forecasted it. But yeah, it was a dud. It wasn't any kind of a geomagnetic storm, sadly. And as far as incoming space weather, both NOAA and ESA are not really forecasting any. So there's NOAA's Enlil spiral. We'll also show ESA's here briefly. And expecting a coronal hole high-speed stream there. They're actually expecting it to be arriving already today, but that's not really what we saw. We saw a coronal mass ejection impact instead. So moving along here to some more stats. There is that's our geospace magnetosphere movie showing Earth's magnetic moment from space out to about 12 Earth diameters, the approximate size of Earth's magnetosphere, and that is the magnetohydrodynamic pressure that a proton would experience as it strikes Earth's magnetosphere from the solar wind. Of course, you can't measure the solar wind from inside the magnetosphere. That's why it's measured 1 million miles away at Lagrangian point 1. Here's our ground magnetic perturbations map. And geomagnetically calm conditions here, so no geomagnetic fireworks going on at the moment. It is pretty chill in the earthly geospace. So that's the past 4 hours of changes to Earth's B field, known as geospace delta B. The units there are magnetic flux density, nanotesla. KP index currently at 1.33. Again, geomagnetically calm, we only got to KP2. And that CME impact that I mentioned earlier did arrive just about when we said, after 12 o'clock Universal Time. In fact, it showed up basically exactly on time there, right about 12 noon Universal Time. So there's the ACE. Solar wind velocity only made it up to about 400 kilometers per second, but you can see a change here in the magnetic fields. The BT-BZ there on the top frame. Also the solar wind density and velocity and plasma temperature all changed there at the same time, an indication of a coronal mass ejection impact. Discover saw a little bit more exciting activity there, but not very exciting. So we did see a brief spike there at 20 protons per cubic centimeter. The velocity at Discover made it up to just over 400 kilometers per second. Current conditions at Discover are 396 kilometers per second for the velocity. The solar wind density, 4.44 protons per cubic centimeter. GOES magnetometers remained pretty smooth here. Again, it was a pretty weak CME impact, not accompanied by strong fields or a strong negative BZ signal, or dense or particularly fast solar wind. So kind of a brush past there by that latest CME impact. Next, looking at the magnetic environment of the heliosphere. And Earth is right now still in a South Pole-oriented magnetic sector, as you can see there. And by tomorrow's video, might still be in that South Pole sector, but will be crossing a current sheet pretty soon, and then entering the North Pole-oriented magnetic sector, depicted here in green. Next, all of the sun's magnetism for the last 4 days packed into one great graphic there from the National Solar Observatory. It's our Gong 2 data. And no major changes happening there. No major changes with coronal holes or sunspots for the past couple of days. Speaking of coronal holes, there's our coronal hole line of sight plot. And we do have more North Pole-oriented coronal holes rotating in here from the east. There's the latest image. And let's cut to coronal holes there from SDO 211 angstroms. That ain't bad. And let me just check something here. Yeah, North Pole-oriented coronal holes are what we've got in the Earth-facing zone. So that's the scenario. Next, moving on to sunspots. Sunspots, sunspots. The number rose modestly. Yeah, modestly. We've got about 125 sunspots at the moment. 125 is the sunspot number, as reported by Royal Observatory of Belgium. And as I've said, the most likely place for a large flare is either on that eastern limb or sunspot 3738. So, of course, we can't really see the magnetic fields of sunspots that haven't risen yet, but we are seeing some activity there from behind the limb. So, of course, large flares happen all the time from behind the limb. It is about a 5% increased probability of a large solar flare when a sunspot is very close to the limb from Earth's perspective. Moving on to sunspots from SDO's perspective. There you have it. The past 24 hours from the HMI instrument there, the helioseismic magnetic imager, the SDO continuum. So we do see some sunspot growth there in the western limb, the northwestern limb. But then some rapid degradation as well. So now we do see some likely sunspots rising. Again, we showed you those prominences. And we'll show you some more imagery of that here in a moment. But first, energetic particles and flares. So, no SEPs, solar energetic particle events. And check it out, an M-class flare going on as we make the video. And let's take a brief look at that from the GOES 16 SUVI. So there are the past couple of hours from the GOES 16 SUVI, and it's actually right on cue. That M-class flare is coming from over here, behind that eastern limb. There you can just see it popping into view right there. So yeah, that's a bit of a self-fulfilling prophecy, isn't it? Anyway, here is the SDO in that same wavelength, 131 angstroms. That is a 24-hour video. And yeah. So flares coming from behind the limb, a thing that we see on the regs on the channel. Anyway, moving right along here, we're going to show a solar system forecast next. And that is where things lie at the moment. We'll show you where things will lie on the 14th. We will be moving into last quarter. Or is it first? I don't know what it is. We'll be moving into a gibbous waxing moon by the 14th. And we'll have both Saturn and Neptune in retrograde, which is what that purple aura means. Retrograde motion, meaning it's just those planets are moving in the opposite direction with respect to the background stars and with respect to the other planets. Next, a quick look at a star chart. That's what's going on at approximately 40 degrees north latitude and 75 degrees west longitude, the location of Lehigh Valley, Pennsylvania. You've got Venus setting ahead of the Sun, Venus and Mercury, and also the Moon. If you've got a low horizon and low light pollution, you might be able to see Mercury after sunset. And let's move on to CMEs, coronal mass ejections. But first, the astronomy photo of the day. So we've got these iridescent clouds over Sweden, also known as nacreous clouds. They are caused by homogeneously sized water droplets in the stratosphere, and it's typically when the sun is at a high angle, when the sun is below the horizon and it's kind of shining across the clouds, and you're getting that refraction there, and that's what's causing that prismatic effect. They're not really oily, it's just water droplets, and it has to do with the homogeneity of the water droplets and their flatness, and of course the sun's angle with respect to them. That's apod.nasa.gov if you want to read about nacreous clouds. So moving on to CMEs, coronal mass ejections, and it's been pretty calm. So we do have a couple events here. We'll let you know if they're earthly directed here in a moment. And let's cut to our custom coronagraphs, because the rest of those are going to be a lot less useful. So there is our custom 24-hour video. We've conveniently synced the SDO along with the LASCO C2 and C3 for you. And you may or may not see the origins of those coronal mass ejections, but when we zoom in here a little bit closer and add the 193 angstrom 60-minute running difference, that should help you. Those are not earthly directed coronal mass ejections, unfortunately, for you aurora chasers. So yeah, things expected to remain pretty calm here. Now, there is going to be a coronal hole high-speed stream on the way. It's just that ESA has forecasted that a little bit earlier than we're really expecting it to happen. But that's what's going on with coronal mass ejections, which brings us to plasma filaments. Plasma filaments, there we go. From Cerro Tololo, Chile, we've got Really 3 pretty dense ones there in the southern hemisphere. One setting in the northwest. Those 2 in the southeast, those are perhaps worthy of being named. And if you don't follow us on X, otherwise known by sane people as Twitter, then you can't name plasma filaments. If you'd like to name them after your friends, your foes, or even yourself, just follow the hashtag #NameThatFilament. Tag @SmashoMash. Let us know which filament and who you'd like it named after. It has to be a living person, as plasma filaments are lively, like most living people. Most living people, especially ones who are not brain-dead zombies. So, but there's the grayscale imagery. It also shows prominences. Again, likely some more sunspots about to rise over that eastern limb. So here are the past couple of hours from the GOES 16 SUVI. Once again, this is 304 angstroms, the ionized helium wavelength. And some activity happening there and on the western limb. Also check out the southeastern limb, which would be your lower left. Some major plasma instability down there. So if you want to name those filaments, I would do it quickly, because those are about to become coronal mass ejections, according to my back-of-the-napkin math. So, bonus features start now. Satellite charging hazards are first, and we ain't got none. It's smooth sailing. The GOES electron flux here coming up off the floor for the GOES 18. The GOES 16 remaining quite low, so a disparity there in the electron flux versus the GOES 16 and the GOES 18. Here's NOAA's forecast model for the electron flux measured at the ionosphere using radiography. And expecting fairly flat levels, no arguments from me there. We'll also show the Australian Government Bureau of Meteorology ionosonde. And there's what's going on in the F layer for the past day. The F layer of the ionosphere. That's about 300 kilometers of altitude, by the way. For those of you who are new to the channel, we show that data most days on the Daily Space Weather Show. So things totally nominal there, as we have not had any geomagnetic storms in the previous day. South Atlantic anomaly is still at the 45-degree west longitude line, as opposed to over the center of the South American continent. So that might be news to anybody who hasn't been watching the channel and known about this for weeks. But you can see it very well on the anomalygram. That depicts anomaly in megahertz from a 30-day median. If you follow the negative 45-degree line there down at the bottom, that'll lead you right to the location of the South Atlantic anomaly, which is kind of right on the South American coast. Facts. Does it tell us something about the pole shift? Probably. Is the pole shift dangerous in any way? Definitely not. Is it even a blip on the geologic radar? Definitely not. Next, the Global Ionosphere Nowcast, or WAM, the whole atmosphere model. Total electron content and maximum usable frequency. Maximum usable frequency. We'll close out on filaments, but before we do that, we'll show you the high-res imagery, especially of sunspot 3738, since that's kind of where it's at. So here is our most likely sunspot to produce a large solar flare, at least the ones that are visible on the solar disk. It remains Beta Gamma Delta class, and especially right in this area right here. That is the area of maximum magnetic shear. And as you can see, we do have multiple active regions here rising in the east. Are any of those sunspots yet? Well, they don't look like it. But what do we have up here? Oh, there's a new sunspot. That one doesn't have a name yet. I think that'll be 3839 if I haven't missed any named groups. So that's what's going on. Again, some major plasma instability in those solar filaments, so we'll keep an eye on those. And when I say ion, well, the pun was intentional. Anyway, that's where we'll close things out. Thanks for tuning in to the Daily Space Weather Show. Congratulations on realizing the Smash News Network least busted name in news exists. And until next time, may that solar wind be at your back. I'm going back to the bunker. What?